Ladies and gentlemen, welcome back to Timeless Talks, where we bring legends back to life. Today, we have a guest who needs no introduction. He's a scientific genius, a mathematician, and a philosopher whose contributions have shaped the world we live in. Please join me in welcoming Sir Isaac Newton. Isaac, could you please introduce yourself with your own words?
Dear David, thank you for the warm welcome. It is an honor to be here on Timeless Talks, sharing my journey with all of you. I am Sir Isaac Newton, born on January the 4th, 1643, in Woolsthorpe by Colsterworth, Lincolnshire, England. My childhood was marked by curiosity and a thirst for knowledge. Growing up, I attended the King's School in Grantham, where my aptitude for mathematics and science began to flourish. At the age of 18, I embarked on a new chapter of my life as a student at Trinity College, Cambridge. It was during my time there that I began to delve deeper into the realms of natural philosophy, as it was known in those days. My studies and experiments led me to make groundbreaking discoveries in optics, mathematics, and physics. Following my graduation, I faced challenging times as England was engulfed in the turmoil of the English Civil War. During this period, I retreated to my family estate in Woolsthorpe, where I delved into my studies and began to develop my most influential theories. It was during my time at Woolsthorpe that the famous Apple incident occurred, serving as a catalyst for my exploration of the laws of motion and the theory of universal gravitation. This pivotal moment paved the way for my groundbreaking work, which was eventually published in my seminal work, Philosophiae Naturalis Principia Mathematica. After the publication of the Principia, I was appointed as Lucasian Professor of Mathematics at the University of Cambridge, a position I held for over 3 decades. Throughout my career, I had the privilege of engaging in correspondence and intellectual debates with esteemed scientists and philosophers of the time, further refining and expanding upon my theories. In addition to my scientific pursuits, I had a deep interest in alchemy, theology, and biblical interpretation. Though these subjects may seem disparate from my scientific work, they played a significant role in shaping my worldview and philosophical outlook. My contributions to the fields of mathematics, optics, and physics have left an indelible mark on human understanding. The laws of motion and the theory of gravitation have become cornerstones of modern science, revolutionizing our perception of the natural world. Now, here I stand before you, grateful for the opportunity to share my journey with you all. I hope that through our conversation today, we can delve deeper into the wonders of the universe and inspire the next generation of thinkers and innovators.
Throughout your life, you made significant discoveries in various fields, from mathematics to physics and beyond. But what initially sparked your passion for knowledge and exploration?
As a young boy, I possessed an innate curiosity about the world around me. I was captivated by the mysteries of nature and had an insatiable thirst for understanding its inner workings. It was during my time at the King's School in Grantham that my intellectual potential began to emerge. At the age of 15, my mother, widowed at an early age, wished for me to become a farmer. However, my lack of interest in agriculture led her to recognize my academic aptitude and encourage my pursuit of education. She saw within me a spark that she knew needed nurturing. It was at the King's School where I encountered the works of ancient philosophers, such as Aristotle and Euclid, which ignited a fire within me. The knowledge they imparted, coupled with the teachings of my inspiring mentors, kindled my desire to unravel the mysteries of the universe. But it was not until my time at Trinity College, Cambridge, that my true passion for learning flourished. Engulfed in an environment of intellectual fervor and surrounded by brilliant minds, I was exposed to a vast array of disciplines and ideas. Mathematics, in particular, caught my attention with its elegance and precision. The pursuit of knowledge became my driving force. I immersed myself in rigorous studies, dedicating countless hours to the exploration of mathematics, mechanics, and optics. The more I discovered, the more I realized how interconnected the workings of the natural world were. Motivated by a deep desire to understand the fundamental principles governing the universe, I embarked on a relentless quest for knowledge. I sought to unravel the mysteries of celestial motion, the behavior of light, and the forces that shape our physical reality. This unquenchable thirst for knowledge, coupled with an unwavering dedication to meticulous observation and experimentation, propelled me forward. I believed that the pursuit of truth required discipline, precision, and a rigorous scientific approach. So, what initially sparked my passion for knowledge and exploration? It was a combination of innate curiosity, the guidance of influential mentors, and the transformative environment of academic pursuit that fueled my insatiable hunger for understanding. I was driven to uncover the secrets of the universe, to peel back the layers of mystery and reveal the elegant mathematical tapestry woven into the fabric of reality.
Your groundbreaking work on universal gravitation is legendary. However, it's been said that your rivalry with Robert Hooke influenced your research, and even led to some controversies. Could you shed some light on your relationship with Hooke, and how it affected your scientific endeavors?
The relationship between Robert Hooke and me indeed played a role in shaping my research and, at times, led to misunderstandings and conflicts. Allow me to provide some context. Robert Hooke was a respected scientist and inventor, known for his contributions to various fields, including physics and microscopy. Our paths first crossed during my time at the Royal Society in London, where I had the privilege of becoming a fellow and later serving as its president. While it is true that our interactions were not always harmonious, it is important to understand that scientific rivalries and disagreements are not uncommon among scholars. The exchange of ideas and challenging of theories is a crucial part of the scientific process, as it fosters intellectual growth and advancement. In the case of Robert Hooke and myself, our differing approaches to scientific inquiry and our contrasting personalities contributed to occasional conflicts. Hooke was known for his experimental and empirical methods, whereas I placed great emphasis on mathematical rigor and theoretical foundations. One of the most notable points of contention arose when Hooke claimed that I had appropriated his ideas on the inverse square law of gravitational attraction. While there may have been some overlapping concepts and discussions, it is essential to recognize that my research on universal gravitation was based on years of meticulous observations, mathematical calculations, and theoretical frameworks. Furthermore, the publication of my seminal work, the Philosophiae Naturalis Principia Mathematica, solidified my explanations of planetary motion and the law of universal gravitation. This treatise, which took years of dedicated effort to complete, stands as a testament to my rigorous scientific approach and remains one of the most influential scientific works ever published. It is true that conflicts and misunderstandings can shape the trajectory of scientific inquiry. In some instances, they can ignite a spark within us, propelling us to delve deeper into our research and refine our theories. While my relationship with Robert Hooke had its challenges, it would be remiss to overlook the impact of these interactions on my scientific endeavors. In the grand scheme of things, it is the pursuit of truth and the advancement of knowledge that matters most. Science is an ever-evolving journey, fueled by curiosity, collaboration, and, at times, healthy competition. Through our conflicts and disagreements, we are reminded of the importance of critical thinking, rigorous analysis, and the relentless pursuit of truth.
As we explore your life's work, one cannot overlook your profound understanding of optics, which led to your development of the reflecting telescope. Can you tell us about the challenges you faced during the invention process, and how it changed our perception of the universe?
The invention of the reflecting telescope indeed posed several challenges, but its development revolutionized the way we observe and understand celestial objects. To fully appreciate the significance of the reflecting telescope, we must first acknowledge the limitations of the traditional refracting telescopes that were prevalent at the time. These telescopes employed lenses to gather and focus light, but they suffered from inherent flaws, such as chromatic aberration, which distorted the observed images. Motivated by my curiosity and a desire to overcome these limitations, I embarked on a journey to design a telescope that would provide clearer and sharper images. The development of the reflecting telescope involved a meticulous exploration of the properties of light, mirrors, and optics. One of the main challenges I faced was the fabrication of high-quality mirrors with precise curvature and smoothness. This required mastering the art of metalworking and polishing, as well as developing innovative techniques to shape and grind the mirrors to the desired specifications. It was through countless experiments and iterative improvements that I was able to create mirrors with the necessary precision. The reflecting telescope, utilizing mirrors instead of lenses, allowed for greater light gathering capacity and eliminated many of the issues associated with refracting telescopes. By carefully aligning the primary mirror and the secondary mirror, I achieved improved image quality and reduced aberrations, resulting in a clearer and more detailed view of celestial bodies. This groundbreaking invention not only revolutionized astronomical observations but also opened new avenues of exploration. It revealed celestial phenomena with unprecedented clarity and allowed for the discovery of previously unseen celestial objects, such as nebulae and galaxies. The reflecting telescope fundamentally expanded our understanding of the vastness and complexity of the universe. Furthermore, my work in optics extended beyond the telescope. Through rigorous experimentation and analysis, I uncovered the nature of light itself, demonstrating that it is composed of a spectrum of colors and establishing the foundations of the field of optics. My prism experiments and the subsequent formulation of the theory of color and light laid the groundwork for our understanding of the behavior of light and paved the way for advancements in fields ranging from physics to photography. In essence, the challenges I faced during the invention process of the reflecting telescope were overcome through careful experimentation, relentless pursuit of precision, and a deep understanding of optics. This invention not only transformed the way we observe celestial bodies but also contributed to our understanding of light and its properties.
One of your most famous quotes, "If I have seen further, it is by standing on the shoulders of giants," demonstrates your humility and acknowledgement of those who came before you. Could you elaborate on the importance of collaboration and the influence of your predecessors on your own achievements?
It is a testament to the humility I held in acknowledging the immense contributions of those who came before me and their influence on my own achievements. Throughout history, knowledge has been built upon the foundations laid by countless individuals who dedicated their lives to unraveling the mysteries of the natural world. I firmly believe that progress is a collective endeavor, where each generation builds upon the accomplishments of their predecessors, standing on their metaphorical shoulders to gain a clearer view of the truth. The importance of collaboration and learning from those who came before us cannot be overstated. By studying the works of esteemed thinkers, such as Galileo Galilei, Johannes Kepler, and others, I was able to build upon their discoveries and insights. Their ideas served as stepping stones for my own inquiries, allowing me to push the boundaries of scientific knowledge further. The pursuit of truth requires an open mind and a willingness to acknowledge that no single individual possesses all the answers. By recognizing and appreciating the contributions of others, we can expand our own understanding and make new breakthroughs. Collaboration and the exchange of ideas allow us to see beyond our own limitations and unlock new realms of knowledge. My own achievements in the fields of physics, mathematics, and optics were not solely the result of my individual efforts. They were made possible by the discoveries and advancements of countless scholars who came before me. Their work served as a foundation upon which I could build and refine my own theories. It is through collaboration and the recognition of the intellectual giants that preceded us that we can truly make progress. Humility is essential in this process, as it reminds us that we are part of a larger tapestry of knowledge, and our own contributions are but a thread in the intricate fabric of scientific understanding. In conclusion, I emphasize the significance of collaboration and the influence of our predecessors in shaping our own achievements. By standing on the shoulders of giants, we gain a broader perspective, enabling us to see further and delve deeper into the mysteries of the universe.
It's well known that your scientific achievements greatly impacted the fields of mathematics and physics. However, some critics argue that you neglected your duties as master of the mint, resulting in financial losses. How do you respond to these claims? And how do you view the balance between scientific pursuits and other responsibilities?
While it is true that I faced scrutiny for the alleged neglect of my duties as master of the mint, I would like to provide some clarity on the matter and share my perspective on the delicate balance between scientific pursuits and other responsibilities. Firstly, I must acknowledge that I am not immune to making mistakes, and I am not impervious to criticism. As a human being, I am fallible and subject to the complexities of life. The responsibilities I held as master of the mint required meticulous attention to financial matters, and there were instances where my focus on scientific endeavors may have diverted my attention from administrative duties. I recognize and take responsibility for any shortcomings that may have occurred during that time. However, it is crucial to understand the context in which these criticisms arose. My scientific pursuits were driven by an insatiable curiosity and a desire to uncover the fundamental truths of the universe. The discoveries I made in the realms of mathematics, physics, and optics revolutionized our understanding of the natural world and paved the way for advancements that continue to shape our lives today. It is important to recognize that scientific progress often requires deep immersion and dedication. The pursuit of knowledge and groundbreaking discoveries demand immense focus and commitment. In my case, my scientific inquiries often consumed my thoughts and occupied the majority of my time. While this intensity may have resulted in occasional challenges in balancing my responsibilities, it is my belief that the scientific advancements made during that period have had a profound and lasting impact on humanity. Furthermore, it is worth noting that my contributions to the field of economics and the reformation of the currency during my tenure as master of the mint should not be overlooked. I implemented important measures that helped stabilize the monetary system, combating counterfeiting and promoting economic stability. In hindsight, one can always reflect upon the choices made and the potential consequences. I have learned from these experiences, recognizing the importance of finding a harmonious balance between scientific pursuits and other responsibilities. It is a delicate endeavor that requires careful management of time, priorities, and commitments. In conclusion, while I acknowledge the criticisms leveled against me regarding the alleged neglect of my duties as master of the mint, I stand by the profound impact my scientific achievements have had on our understanding of the universe. I am also aware of the importance of finding a balance between scientific pursuits and other responsibilities. As I continue to reflect upon my journey, I hope my contributions to the fields of mathematics, physics, and optics will be viewed with the recognition they deserve, while also recognizing the complexities of navigating multiple roles and responsibilities.
Your work on calculus is highly regarded, but it's been suggested that your priority dispute with Gottfried Leibniz overshadowed your contributions to the field. Can you share your perspective on this controversy and its impact on the development of calculus?
The controversy surrounding the development of calculus and the priority dispute with Gottfried Leibniz is indeed a topic of discussion that has persisted over the years. It is undeniable that both Leibniz and I made significant contributions to the field of calculus, independently developing different approaches to the mathematical framework. Leibniz introduced the notation and concepts of differential and integral calculus, while I developed the method of fluxions and the fundamental principles of calculus. The dispute arose when claims were made regarding the priority of these discoveries. In retrospect, I must acknowledge that my response to this controversy was fueled by a desire to protect and preserve my own intellectual achievements. I engaged in a bitter and protracted dispute with Leibniz, at times resorting to harsh and critical language. Looking back, I recognize that this dispute hindered the progress of mathematics and the broader understanding of calculus during that period. While the controversy may have cast a shadow over my contributions and delayed the widespread acceptance of my work, it is essential to recognize that the development of calculus is a result of a collective effort over time. Mathematics is an ever-evolving discipline, built upon the work of numerous individuals who came before us. It is through the collaboration and exchange of ideas that progress is made. The calculus controversy ultimately spurred further investigations and advancements in the field. Scholars and mathematicians, in the pursuit of clarity and understanding, delved deeper into the principles and applications of calculus. It is through this process that the full power and potential of calculus were realized, benefiting generations to come. In retrospect, I recognize the value of collaboration and the importance of acknowledging the contributions of others. The dispute with Leibniz taught me the significance of fostering an environment of intellectual exchange and mutual respect. It is my hope that the controversies of the past serve as lessons for the future, encouraging scholars and researchers to embrace a spirit of collaboration and open dialogue. In conclusion, while the priority dispute with Leibniz may have caused distractions and delays in the acceptance of my contributions to calculus, it is imperative to focus on the collective progress made by mathematicians throughout history. The development of calculus is a testament to human ingenuity and the power of intellectual collaboration. Let us continue to build upon the foundations laid by those who came before us and strive for further advancements in the fascinating realm of mathematics.
Beyond your scientific endeavors, you delved into alchemy and theology, subjects that might be considered unconventional today. How do you reconcile your pursuits in these areas with your scientific mindset, and what insights did you gain from these explorations?
While my scientific pursuits in the fields of physics and mathematics are widely known, it is true that I also dedicated significant time and effort to the study of alchemy and theology. Alchemy, in my time, was not the esoteric and mystical practice it is often perceived as today. It was considered a legitimate field of study, closely related to natural philosophy. My interest in alchemy stemmed from a profound fascination with the workings of nature and the desire to uncover the hidden secrets of the physical world. I approached alchemy with the same meticulous attention to detail and systematic approach that guided my scientific investigations. Through my alchemical experiments, I sought to understand the transformation of substances and the underlying principles governing matter. While alchemy did not yield the grand transmutations that were often sought, it provided me with invaluable insights into the nature of chemical reactions, the properties of materials, and the concept of the conservation of mass. These explorations laid the groundwork for the later development of modern chemistry. In terms of theology, my interest arose from a deep-rooted belief that the study of the natural world and the understanding of divine creation were intertwined. I saw theology as a means to gain a deeper understanding of God's design and the underlying order of the universe. It is important to note that my theological pursuits were deeply personal and were not intended to interfere with my scientific inquiries or compromise the rational and empirical approach I took in my scientific work. Through my theological studies, I contemplated the nature of God, the origins of the universe, and the relationship between the physical and the divine. While these questions were philosophical in nature, they helped shape my worldview and influenced my scientific endeavors. I firmly believed that the natural world operated according to divine laws and that the pursuit of scientific knowledge was, in fact, a means of uncovering the intricacies of God's creation. In reconciling these seemingly disparate interests, I maintained a disciplined and rational approach. I understood that the methods employed in alchemy and theology were distinct from those of scientific inquiry, yet I saw value in exploring different avenues of thought and observation. It is through this interdisciplinary exploration that I gained a more holistic understanding of the world and expanded the boundaries of my scientific pursuits. In conclusion, my pursuits in alchemy and theology were driven by a genuine curiosity and a desire to unravel the mysteries of nature and divine creation. While unconventional by today's standards, these explorations provided me with valuable insights and influenced my scientific mindset. They allowed me to approach the study of the natural world from multiple perspectives, enriching my understanding and contributing to the advancements I made in the fields of physics and mathematics.
Your Principia Mathematica is hailed as one of the most important scientific books ever published. However, it's also known for its complex and rigorous mathematical formulations, making it challenging for many to comprehend fully. How would you explain the significance of your work to someone who might find it intimidating?
The beauty of the Principia Mathematica, a work that has indeed left its mark on the scientific world. While it is true that the mathematical formulations within its pages can appear complex and daunting, allow me to shed light on the significance of this work and offer an explanation that strives for accessibility. At its core, the Principia Mathematica represents a monumental achievement in the understanding of the physical world. Its purpose was to provide a comprehensive mathematical framework that explains the motion of celestial bodies and the workings of the universe. Through this work, I laid the foundation for the laws of motion and the theory of universal gravitation, which have since become pillars of modern physics. Now, I recognize that the mathematical language employed in the Principia can be intimidating to those who are not well versed in advanced mathematics. However, it is important to note that the concepts and principles conveyed by these mathematical expressions can be grasped through intuitive explanations and analogies. First and foremost, the Principia establishes the three laws of motion. These laws describe the fundamental principles governing the behavior of objects in motion, whether they are planets in the heavens or bodies on Earth. They offer a logical and elegant explanation for the observed phenomena, such as the elliptical orbits of celestial bodies and the falling of objects under the influence of gravity. To make these laws more accessible, one can think of them as common-sense principles that govern the way objects move in our everyday lives. For instance, the first law, also known as the law of inertia, states that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an external force. This is akin to the experience of pushing or stopping a moving object. The second law introduces the concept of force and its relationship to mass and acceleration. It tells us that the force acting on an object is equal to the mass of the object multiplied by its acceleration. This can be related to the experience of exerting force on an object and observing how its motion changes in response. Lastly, the third law states that for every action, there is an equal and opposite reaction. This law highlights the interconnectedness of forces and their interactions, whether it be the recoil of a firearm or the gravitational attraction between two bodies. Now, when it comes to the theory of universal gravitation, it may be helpful to envision a world where invisible threads connect all celestial bodies, guiding their movements. The force of gravity, which attracts objects to one another, is proportional to their masses and inversely proportional to the square of the distance between them. This concept allows us to understand why the planets orbit the Sun and why objects fall to the ground on Earth. In essence, the Principia Mathematica is significant because it provides a mathematical framework that elegantly explains the workings of the universe. While the mathematical language used may present a challenge, the underlying principles can be understood through intuitive explanations and relatable analogies. By exploring and appreciating these principles, one can unlock a deeper understanding of the natural world and the remarkable laws that govern it. Remember, my goal as a scientist has always been to make the wonders of the universe accessible to all who seek knowledge. So, fear not the complexities of mathematics, for the beauty of the universe awaits those who dare to explore and comprehend it.
Your Principia Mathematica is hailed as one of the most important scientific books ever published. However, it's also known for its complex and rigorous mathematical formulations, making it challenging for many to comprehend fully. How would you explain the significance of your work to someone who might find it intimidating?
The Tale of the Apple Tree, a story that has been passed down through the ages and gained a place in the collective imagination. While it is true that I had a profound moment of insight regarding gravity, it was not as dramatic as an apple falling directly on my head. The story, as often retold, is a simplified version of what actually transpired. You see, it was during my time in Woolsthorpe, when I was sitting beneath the shade of an apple tree, that I witnessed a humble apple falling to the ground. Now, this observation, seemingly insignificant to some, sparked a chain of thought within my mind. I began to contemplate the forces at play, the nature of motion, and the idea that perhaps the same force that brought the apple down to the ground also governed the motion of celestial bodies. This moment of reflection laid the foundation for my subsequent studies on gravity and the formulation of the laws of motion. The true significance of this anecdote lies not in the apple itself, but in the power of observation and the inquisitive nature of the human mind. It serves as a reminder that scientific breakthroughs often stem from keen observation and a willingness to question the world around us. It was through careful observation, meticulous experimentation, and rigorous mathematical analysis that I was able to unravel the laws governing motion and gravity. In the realm of science, the process of discovery is a continuous and iterative journey. It involves observing natural phenomena, formulating hypotheses, conducting experiments, and refining our understanding through careful analysis. The apple tree anecdote symbolizes the pivotal role of observation, curiosity, and the pursuit of knowledge in the scientific process. So, while the apple did not directly fall on my head, its humble descent did provide the inspiration and impetus for my inquiries into the fundamental workings of the universe. The story serves as a reminder that even the simplest observations can lead to profound discoveries when approached with a curious and analytical mind. In reflecting upon this tale, we are reminded of the power of observation, the inquisitive nature of science, and the potential for great discoveries hidden within the everyday occurrences of our lives.
Finally, Sir Isaac Newton, you have left an indelible mark on the world with your contributions. Looking back on your life and achievements, what would you consider your most significant legacy, and how do you hope to be remembered by future generations?
As I reflect upon my life's journey and the contributions I have made to the realm of knowledge, it is a profound question indeed. What shall be my most significant legacy, and how do I aspire to be remembered by future generations? In the realm of science and mathematics, I am humbled by the impact my discoveries have had on our understanding of the universe. The formulation of the laws of motion and the universal law of gravitation, as presented in my work, Philosophiae Naturalis Principia Mathematica, stands as a cornerstone of scientific understanding. Through meticulous observations, rigorous experimentation, and the application of mathematical principles, I sought to unravel the mysteries of the natural world. My hope is that future generations will recognize the power of observation, the importance of mathematical reasoning, and the pursuit of knowledge based on empirical evidence. I desire to be remembered as a scientist who placed great emphasis on the scientific method, emphasizing the role of experimentation and mathematical analysis in uncovering the truths of the universe. Beyond my scientific endeavors, I ventured into diverse areas of inquiry, delving into alchemy, theology, and biblical chronology. Although these pursuits may be viewed as unconventional today, they reflected my insatiable curiosity and my belief that there is wisdom to be gained from exploring the intricacies of the natural world and the divine order that governs it. In essence, my most significant legacy lies in the spirit of intellectual curiosity, disciplined inquiry, and the relentless pursuit of knowledge. I hope to be remembered as an individual who devoted his life to unraveling the mysteries of nature, contributing to the foundation of modern science and inspiring generations to come. May future generations continue to build upon the knowledge I have left behind, pushing the boundaries of human understanding and seeking answers to the questions that have yet to be asked. It is my aspiration that they will find inspiration in the wonders of the universe and strive to make their own profound contributions, expanding the frontiers of knowledge for the betterment of humankind.
Well, there you have it, folks. A thought-provoking and insightful interview with Sir Isaac Newton. Join us next time as we continue to unravel the minds of history's greatest thinkers on Timeless Talks. Until then, stay curious and keep exploring the wisdom of the past that guides us forward.